over a frictionless pulley as shown above. If both mass remains at rest means the acceleration is 0 here. An angle of inclination is 30 degrees. What's the coefficient of static friction? In this question, it is asking for the static friction of the system here. But before answering the question, let's draw the free body diagram for both masses. So for M1, here is the force of tension, because there is a string here, so it is a tension. And here is the mg for the ball. Don't forget to label the masses. So here it will be m1g, in order to not be confused during writing the formula. And the free body diagram for the m2. The normal force is always perpendicular to the surface, F normal, and the mg is always downward whenever the situation is always downward. Don't forget to label it m2g. And now, and also here is tension. But in this question, there is a tricky thing that it mentions here. Two 5 kilogram objects are 5 kilograms. So both of them are having the same mass. So what will be the direction of the motion of the object? Is it here or here? In this situation, you decide where is the direction of the object. So if you selected that the motion of the object is in this direction here, this m1g will be negative. This mg1 will be negative. Why? Because this m1g resists the motion of m2. Whereas if you decide to make the object move in this way, this the gravitational force, the x component of the gravitational force will be negative, even if it is right, because it resists the motion of the object, because the object is moving. The object is moving in this direction. The object is moving in this direction, and the mx is resisting the motion, so it will be negative. But in this situation, I will choose that the object is directed this way, is moving in this way. So, as I have mentioned, the motion is moving in this direction, so m1g will be positive, and the mx, the m2x will be negative. Why? Because it resists the motion. After writing the free body diagram, let's write our equation. So we will use here this situation, the system approach, in order to find the static friction. But before that, we haven't tried the kinetic friction. So if the motion was directed in this way, the friction will be the same as Wx. Here is the tension, F kinetic. So let's write our equation. Also, the F kinetic will be negative. Why? Because it resists the motion. Friction is always negative, in fact. So let's write our equation. It will be A system is equals to external forces over total mass. Here in this situation, the acceleration is 0. Why? Because it resists the motion. It is negative because it resists the motion. So it will be 0 equals, what are the external forces? The external forces are m1g, the F normal and the y component cancels out, and the mx, also the F kinetic. But what will be the signs for each force? As I have mentioned, the object is accelerating, or in other words, moving in this direction. So the M1G will be positive, even if it was down. M1G. Now, the MX resists the motion, so it will be negative. Minus M2X, means the X component. I will expand it within the equation. And minus F kinetic. F static. Not kinetic, my mistake. It is F static. Over the total mass, that is M1 plus M2. Let's expand our equation. 0 equals to M1G minus M2G sine theta. Why it is sine theta? Because here it is opposite to the angle. It is opposite, and sine is sine equals to opposite over the hypotenuse. That's why it is sine theta. Minus the equation for the F static is mu static multiplied by the normal force. So it will be F static normal force over M1 plus M2. Now let's expand it more. It will be 0 equals to M1G minus M2G sine theta minus static coefficient. The F normal is mg cosine theta, M2G cosine theta, because it is adjacent over hypotenuse. So it will be M multiplied by M2G cosine theta over the total mass M1 plus M2. Now let's substitute our numbers. 0 equals, what is the mass of M1? It is 5 by 9.8 minus 5 by 9.8 sine of 30 minus unknown static coefficient multiply by the 5 9.8 cosine 30, over the total masses, that is 5 plus 5. Total masses 5 plus 5 is 10. 0 equals, now just plug all of these, now plug these numbers in your calculator, and you will result with F static equals to, result with 0.577, which nearly equals, when you round it to the nearest tenth, 0.58. It is unitless. There is no unit for static friction. And that's the ending for video. And physics is easy with Mr. Jesse always. With the thought of Mr. Jesse.